Next we have Shannon Capps, and she is on the air quality team.
I'll take time to introduce Jana Milford, for whom I work, and she has a lot of expertise in both air and legal implications of things that go on with air, so if you have questions for her later, I'm sure she'll be happy to answer. So we want to try to understand whether energy choices that we make individually or societally can impact atmospheric composition, both in greenhouse gases and in air quality that would have impacts on health or public welfare. So to understand that, we would want to know that our choices in efficiency, like whether we get an efficient light bulb or drive a different kind of car, actually has an influence on the type of fuel that is used to produce that outcome. So these are maps that show changes in reductions in coal to produce electricity and increases in natural gas over time with geographic diversity from 2001 to 2014. We can look at that in aggregate across the whole US in this map or in this graph and see that coal has decreased, natural gas has increased, and then we have things that are actually producing far less pollutants, contributing a smaller fraction of our electricity. So the reason we care about that mix is because those different activities like coal and natural gas have different impacts on things like methane and other atmospheric emissions. So methane is a greenhouse gas, and we can see here that even from space with a satellite sensor, you can see changes from 2006 to 2011 in the concentration of methane in areas where you have increased oil and gas activity. Also from space, we can see changes in CO concentrations from places where lots of people live and burn fuel, or where much biomass burning is occurring. So CO is something that is more related to air quality, as is ozone. So you know that stratospheric ozone is a great thing, but when we have more ozone produced at the ground level, we actually have health impacts and reduced productivity of trees and crops. And so two things are necessary to make ozone: oxides of nitrogen and volatile organic compounds. And those are emitted through transportation, fuel combustion, and what we're interested in, oil and gas activity. So we have smaller contributions from certain activities than others. And what we can do is estimate emissions from that whole suite of activity and use a model with lots of math to calculate the concentration of ozone and other air pollutants. So this is an example of one outcome of a regulated quantity of ozone that the EPA says you can't have above a certain amount of ozone across a certain time period per day. And so that's just an example of the outcome of a model. And the reason we like to use models is because we can easily say, what if we changed the emissions from a certain process or made a different choice in the energy sector, and that actually altered the volatile organic compound emissions. So in order to use that atmospheric model, we need to understand accurately how we might change emissions by choosing different resources that are more renewable and have lower emissions, or for instance, by increasing efficiency. So we have another model that we couple with it to do that. This takes into account the type of fuel that we're using, the way it's converted into energy, and then how we're using it, down to the particular type of light bulb you might have. We're looking at energy scenarios from 2010 to 2050. Three things we're evaluating. One, what if the cost of different types of fuels changed? How would that impact energy choices made by the model that is trying to optimize the economics of the system? Secondly, what if we use regulations to drive down greenhouse gas emissions? How would that impact not only greenhouse gas emissions, but also air pollutant emissions? And finally, what if we made particular technologies more deployable more quickly? For instance, in this case, electric vehicles. So we want to try to understand how these different forcings on the system would impact the energy mix and how that would affect volatile organic compound emissions and nitrogen oxide emissions. So on the left, you have the 2010 base case and 2050. The main takeaway is that we can, by having different costs in gas, impact things as much as with regulations, and that in the greenhouse gas emissions. We do see an impact from production of methane. That's the hashed part here. So when we have natural gas being used, it actually is evident in those total emissions from the energy sector. So the conclusion is just that we have these two sets of models that we can bring together to understand greenhouse gas concentrations as well as pollutants that would impact human health. So thank you. I'll be happy to talk with you more later.